Idea actually is, if you actually go to Mars, as Magdalena said, it makes actually way more sense to have small villages instead of maybe a big city or so. But even the villages will be quite vulnerable because, as we know, the Mars is not the most friendly environment. So there are quite hostile things on Mars. Like, for instance, there is no atmosphere, so we don't actually have any breathable air. There is not really a magnetic shield or a magnetic field around Mars, so there is actually quite some radiation, as everybody may know. There's dust storms, and there's a lot more we may not even actually know, but just to name a few. What would be an obvious choice? For me, a solution would be actually to go underground. What techniques actually do we have that's available on Earth today? So there's two main techniques. Actually, we've got drilling and blasting. Drilling and blasting is a cycle, and the cycle actually is beginning with you create blast holes with an underground drilling machine, like the one you see in the picture down there. So basically, you drive the machine towards a rock face, you drill a couple of holes in there, then after that, you actually stick some explosives in the thing, then you actually then you ignite it, yeah, and you get a whole lot of rock basically that's broken down, which needs to be loaded, transported away from the site. Then after that, you actually have a very unstable surface, or a rock face that is normally in need of support, so that you actually do scaling. So that means you remove loose rock, you add ground support, as in rock bolts, to actually help the rock sustain the weight, and you add mesh or shotcrete in to actually keep rocks from falling down for future things. And the whole drilling and blasting is a cycle, so actually it's repeating itself. When you have done that, you actually start again with creating blast holes and charging and loading. The other technique you actually find is cutting and shearing. I'm not actually going into shearing because that's only for soft rock, but cutting is actually a continuous mining method where cutting or shearing head actually is engaging the rock face all the time. So it's continuously actually driving forward through the rock. These are like examples which Atlas Copco, or it's now called Epiroc, is actually testing at the moment for hard rock mines. This is called the mobile miner. You also got variations here from a company that's called Sandvik, that's roadheader, and those machines actually have a capability, as I said, that it's actually a continuous drive. So they actually break the rock. All the rock is actually falling to the ground. It's being picked up, transported by a feeder through the machine into like a shuttle car, a bin, or normally a conveyor belt. So you actually see it like the drop here, which is sort of actually a conveyor belt that's going through the machine. As normally actually end up, on the other hand, is ground supports that you actually have to do as well. The question now actually is, what's the resource usage? Because, you know, Mars doesn't actually have any supplies, obviously. So what do we actually need for drilling and blasting? Yep, you need electric power to actually run the rig, to run all the machines. You actually need water to actually keep drilling the holes, to water down the surface and to water down the explosive rock. You actually need operators. You do need explosives. And you need the ground support and consumables for the machines you find. For cutting and shearing, what do you need? Actually, electric power, obviously. The machine is running continuously on 1000 volts. Water can be applied, must not necessarily be applied. Normally you actually use water to cool down the drill bits. So that's the only thing or actually use for shotcrete, but that's the only thing, the only application actually you use water for in cutting. And you may have one or two operators at the face or actually on remotes. And you do have your ground support and consumables as well. So the question is now, What would be the obvious choice? What's the most applicable on an extraterrestrial body? Drilling and blasting, a method that's actually in a circle. You have a drilling machine, drill machine has to move. You actually have, after that, you have the guys who are coming in doing the charging. If that's done, another machine is coming in for transporting the rock. And after that, another machine is coming in for actually doing the ground support. So there's like a lot of steps with different machines. Is it possible to automate, which would be a great help actually in an extraterrestrial body? Yes, to some parts it actually is you can automate it, but not the whole chain. So you will have to have people in front on the face who are actually working. And resource consumption, as I said, you have water, you have electricity, you actually have explosives. So I don't see that you actually can create explosives on Mars at this stage. I don't actually know that if you will have the quantities of water that is actually necessary to run a drill rig, which is running about 150 liters per minute. So that's extremely amounts of water. So on the comparison cutting, what do you need? As I said, actually it's a continuous operation. So you're actually running it 24/7 on the face, it's running, and you don't actually need to do much. Can you automate it? Yeah, absolutely. I actually know a few trials that actually have been done where the operator basically was sitting on the surface in an air-conditioned control room, and the machine is basically working underground. Yeah, that's possible. And the resource consumption, yep, we can agree that there is actually a resources that the machine obviously is consuming, but I actually think that's an engineering question, and it's not out of the question to actually do it. So choice, drilling, blasting, I don't think so. For me, the obvious choice would be cutting. So, and how do I think that it actually can work? Yep, as I said, a continuous miner can be actually remotely controlled. Yeah, nowadays all the machines actually come with a cable, as I said, with a 1000-volt supply. But it is actually possible to engineer a power pack. And the power pack for the machine can be either the machine actually has to drive to charge, or you actually have maybe a shuttle car that actually delivers a battery from a charging station to the machine every time it actually needs to be replaced. So that's an engineering solution that can definitely be solved. The rock transport. As I said before, among all the villages out there, you will actually have a base before you actually can go underground. Obviously, you will have to establish some sort of village outside before you actually can start working underground. And we actually can agree that most of the stuff of the villages would actually help if you dig them in. So you actually have mined resources that you actually can use in order to cover up your villages or your village domes or whatever you actually are planning to, in order to shield those villages from radiation. That's one thing, and actually the material you're actually taking out you can actually use to create the consumables you actually need to cut the rock. Transport itself, as I said before, you can actually have shuttle cars that actually do the rock transport for you. And the shuttle cars actually, even today, are already automated. So that's not actually a big deal. The consumables is another question. Because, as I said, the machine is actually continuously working the rock face. So there's obviously, like you see in the pictures here, drill bits or hammer bits or rollers, as you see in here, that are basically constantly engaging the rock surface, and obviously there will be some wear and tear. I do think that it is possible to actually manufacture them out of Martian rock. They won't be as good as the ones you actually get at Earth at the moment, but I think it will survive, and we may actually be able to blend in some other metals to actually get some strong and more wear and tear resistant tools. So, and yeah, as it actually said in the last one, I think you actually can even 3D print that. So if you actually create like a slurry out of that and maybe mix in some other materials you actually have to actually create those, then I think this actually can work. A few things to think about though. At the moment, continuous miners, as they're called, are having actually a little bit of a limited limitation on them, because at the moment they are only considering going up to a certain rock strength. The ones I actually showed earlier in the slides, those mobile miners, they are actually designed for hard rock. So those would be definitely applicable in that case. And as I said, the tools. Yep. 3D printing is definitely the way to go on these ones. And I actually think it's also possible to actually have some sort of delivery method to actually deliver the consumables from this 3D printing to the machine, switch them out, and get the machine back in operation. And I think that can be done without actually human interaction. So the idea actually is you remove all the personnel that actually needs to be there at the face in order to actually have them in a safe, pressurized location. You actually do the mining, you can actually even use the material that's coming out. So I think it's sort of a win-win. And the only thing what I actually haven't said now is, why do I actually think we should do the mining? Because obviously my title was that we are mining for resources and habitats. I was talking about the resources all the time. But as I said, the habitats, if you're actually creating all the underground infrastructure, it would be actually a shame if you're not using it to actually be able to house in there. So I assume at the long run, you will have the villages will have their applicable until you actually have created all the underground space, and then you actually will move into the underground space. I mean, you can have all the factories and all the living quarters and everything down there, and it's not necessarily that everything on the surface will vanish. It may be actually that they will correlate surface time as well with like sun or other things as well that you actually want. So it will be, I think, a bit of a mixture between underground structures and surface structures that actually coincide. That's actually my fantasy. And I think that would be actually even a doable fantasy. So we'll see what happens in the future. But yeah, that was actually so much to my presentation. So I'll probably leave it back over to Meg if you have any questions or something.